Dear students, good morning to all. We will see the definition of degrees of freedom. The definition is the minimum number of independent variables. Independent variables means here x, y, z required to describe the state of the position of the system. That is called degrees of freedom. So, how we specify the degrees of freedom depends upon the choice of origin. We know that we had studied in mathematical physics Cartesian coordinates, cylindrical coordinate, then spherical coordinates, then center of mass versus individual particles. If the system is a single particle, the Cartesian coordinates, that is x, y, z, are expressible as functions of the generalized coordinates. The topic on generalized coordinates we will discuss later next session. For the motion on a curve is 1 degree of freedom, that is x is a function of q only. The motion on a surface is for a particle moving in a surface, it has 2 degrees of freedom. Then it will occur in phase, it has 3 degrees of freedom. Suppose this is our coordinate system, that is x, y, z. It consists of x, y, z. If I want to specify one mass point with respect to origin, it is at x, y, z. This is the position of mass point. In our real life example, when a single particle moves in space, it is when a single particle moves in space, it has 3 degrees of freedom. For example, a bird flying in the sky. When a single particle moves in a plane, it has 2 degrees of freedom. Then an ant moving in a straight line, it has 1 degrees of freedom. This is the example for degrees of freedom. In a rigid body, it has 6 degrees of freedom. That is 3 translational movement and 3 rotational movement about 3 perpendicular axes. And translation movement, surge means moving forward or backward, have means moving up or down, sway means moving left and right. Then rotational movement, we have roll, pitch and yaw angle. Roll means tilting side to side, pitch means tilting forward and backward, and yaw means turning left and right. So totally we have 6 degrees of freedom. Explains the 3 translational and 3 rotational degrees of freedom. It can move along the 3 axes Cartesian coordinates x, y, z, forward and backward on the x-axis, left and right on the y-axis, up and down on the z-axis. And 3 rotational movements are made. It can roll on the x-axis, it can pitch forward and backward on the y-axis, it can rotate yaw in the circle on the z-axis. In this session, we had derived kinetic energy of a system of particles in terms of the position vector of center of mass, and we had a little knowledge about degrees of freedom. Then next class we will learn about constraints types of constraints, holonomic and non-holonomic constraints, Reynolds and Skolanovic constraints, and configuration space and space. So thank you one and all.